Hey guys, welcome to part 2 of the 7D notes. This is 7D day 2. This is where things get a little bit more complicated. So if you felt like the missing angles part was easy, this is where it gets a little bit more harder. But if you're good at cross multiplying, this should be no problem. And if you're good at trigonometry, it should be a breeze. But it's about sizing things up. So once again, if you guys have the 7D notes day 2, what you guys can do is open it up and look here. Now I'm going to do some of these. The ones I don't do, I want you guys to try out and then compare them to the notes that are accompanying it with the answers, obviously. So first things first, once again, you need to make sure that your calculator is under the settings of degree. If they're not in degree, it's not going to work for you. You'll get a different answer because of the different ratios. So let's go to calculate. Now on this side it says, hey, find sine of 40 degrees. Well, we know how to do that. That is easy. Here's 40 degrees, and remember, sine is the opposite over the hypotenuse. So this would be your, let's see, opposite and hypotenuse, right? So then we know that would be sine of 40 degrees is equal to our opposite over our hypotenuse, so it would be 5 over 13. Easy enough, right? So here it wants us to find cosine of 40 degrees. Cosine of 40 degrees, well remember, cosine is going to be your adjacent and your hypotenuse. So this would equal 22 over 37. Not hard. Here it wants us to find tangent of 40. So this would be your opposite. This would be your adjacent. So your tangent of 40 degrees would be the opposite, which is 10.2 over 12.5. Now, this is just to kind of show you how we kind of set these up. So you're always going to kind of say, hey, what trigonometric ratio am I using? What function you're using with the degree equal to a fraction. That's how this is going to be set up. It's usually going to be sine of something equal to a fraction, cosine of something equal to a fraction, tangent of something equal to a fraction. Now, usually that part of the fraction is going to have a missing part. So for instance, in number 1 here, we are trying to find the missing side of this angle. Now, in these situations, they will always give us one angle and one side and then ask us to find a side. We can actually find either side here. We can either find this side or this side just with an angle and knowing one of the sides in a right triangle. Now, typically how they set this up is that they gave us a side. Well, this is the side. Is this the opposite, adjacent, or hypotenuse? Well, this would be the hypotenuse. What did they ask us to find? This side, which is the opposite. Now, if you notice, they only gave us these two sides to work with. The one we don't know and the one that we know. So then think about it. Which function uses opposite and hypotenuse? Well, if you remember SOHCAHTOA, you would know that the opposite and hypotenuse, O and H, would be a sine equation. So what we're going to do is write this out as sine of 75 degrees is equal to the opposite over the hypotenuse. So it would be the opposite over the hypotenuse. So this is step 1. What we're going to do now is plug things in. Let's actually write it over here because we'll have more room. We're going to have sine of 75 degrees is equal to our opposite, which we don't know, over the hypotenuse, which we do know, which is 15. Now, what we're going to try to do here is cross multiply. But if you notice, we only have 3 pieces here. We need 2 fractions to cross multiply, don't we? Well, what we're going to always do is, you see we have this sine of 75. We're going to put this over the number 1. Why do we put it over 1? Well, because it doesn't change anything. Sine of 75 divided by 1 is still sine of 75. It won't change anything, but it does turn it to a fraction. Any whole number or anything can basically be divided by 1, not changing anything. So then, once we have this part here, we're going to cross multiply. So we're going to multiply these two together, and we're going to multiply these two together. So if you're wondering, how do I multiply sine of 75 times 15? Well, just like what we did before, I would put the 15 in front. It'll be easier to see, 15 times sine of 75, because all I did was multiply these two things together. And that's going to be equal to the other one, and this one's easy. X times 1 is just x. At this point, we're done. X is by itself, and then we can just throw this in your calculator. So we're going to calculate this. So then how do you put this in your calculator? Well, I would just put 15 times, don't forget we use this trig button, sine of 75. Then you hit enter. And that's what we got. So then x would be equal to, what is this, 14.48, but then there's another 8, so it'd be 49. And we just found our missing side. So let's look at another one. Let's look at this one here. Once again, we're looking from 60 degrees. Well, first things first, label. What did they give us to work with? They gave us this 50, which is our adjacent ADJ, and they gave us this x here, which is our opposite. So I only have these two pieces to work with. We don't really care about this side because we're not really interested in it. So then which one uses opposite and adjacent? O and A would be tangent, TOA. So then we know this will be a tangent equation. It will be tangent of 60 degrees, because we're looking from that angle, is equal to the opposite divided by the adjacent. Uh-oh, there's a cat coming. There's a cat coming. Hi, Nova. Yeah, I'm doing work. Oh, are you going to be my new mascot? Love you too. I know. You're going to go in here. Everyone say hi to Nova. Say hi, Nova. Okay, let's put you in your pillow. All right, you stay there. Be a good girl. All right, so let's take our opposite, which is x, over the adjacent, which is 50. Once again, let's skip a step and let's just put this over 1, right? Now we're going to cross multiply. We're going to take tan of 60 times 50, and we're going to take this x times this 1. I'm a little bit out of room, so let's just put it right here for now. The 50 times tan, we're just going to write as 50 times tangent of 60 is equal to x times 1, which is just going to be x. And if you're left with x on one side, you're done. It's easy. Just put in your calculator. Calculator. So let's put this in. 50 times tangent of 60. Hit enter. We get 86. 86 point, what is this, 602, 2 rounds down, so it'll just be 86.6. Good enough. And that's it. So we're using these to find missing sides in triangles. Let's look at some harder cases. Let's see if I can find our case. Okay, number 6 is going to be a little bit harder, and I'll show you why. I'm going to write it right here. Once again, we're looking from 61. That's the piece we're looking from. Label. What did they give you to work with? Well, this is our opposite, and this one here is our hypotenuse. Well, what function uses opposite and hypotenuse? Sine does. Sine of how many degrees was it? 61 is equal to the opposite divided by the hypotenuse. Now, you can skip this step entirely and just go into the second step, which is going to be sine of 61 is equal to our opposite, which is 19, divided by our hypotenuse, which is x. We're going to put this side over the number 1. Because it's easy and makes it into something we can cross multiply. Now, if you notice something, the x is on the bottom this time. What that means is that we're actually going to have to do an extra step here. Watch though, watch what happens. So let's multiply these two together. Sine of 61 times the x, just like we do, 19 times 1. Once again, put that x in front, whatever's there. X times sine of 61 is equal to 19 times 1, which is just 19. Now, if you notice, our x is actually not by itself. It's x times sine of 61. Well, how do we solve for x? Well, notice how it's being multiplied, and obviously the opposite of multiplying is to divide. So what are we going to divide? Well, we're going to divide by that sine of 61. I know it looks complicated, but essentially you're just going to divide. Anytime we have an x in the bottom, you're just going to do an extra divide step. Sine of 61 divided by sine of 61 will, of course, cancel because they're the same thing. We're left with x is equal to 19 divided by sine of 61. How do we put that in your calculator? Just how you think you would. 19, if you want to be fancy, you could do divide, trig, sine 61. Just like that. Then hit enter. And we get 21.72, the 3 rounds down, so it would be 72. And that's it. Let's look at one last one before we end this video. Let's see. No, that would be an easy one. This one here would be, yeah, let's do number 7. Number 7 is going to be another one with division. How do you know? X is on the bottom. So step 1, we're looking here. Label everything. Well, this x here is actually your hypotenuse. This 7 here is your adjacent. Remember, your opposite side would be over here. We don't even use the opposite side, so we don't even need it this time. Now, what function uses hypotenuse and adjacent? Cosine does. So this is going to be a cosine equation. Cosine of how many degrees? 30 degrees, because it's 30 degrees. Equals to the adjacent over the hypotenuse. Once again, you could skip this step if you're quick. So we're going to say cosine of 30 is equal to our adjacent, which is 7 over our hypotenuse, which is x, and we're going to put this one over 1. Then we're going to cross multiply. Cosine of 30 times x and 7 times 1. I'm going to write it over here just because I'm out of space. All right, what is cosine of 30 times x? Well, let's put the x first. X times, remember it's cross multiplying, so x times cosine of 30 is equal to 7, which is 7 times 1. This times this. All right, once again, x is not by itself here, so what we're going to have to do is do the opposite multiplying and divide. Divide by cosine of 30 and divide by cosine of 30. These two will cancel out, and you're left with x is equal to 7 divided by cosine of 30. Well, we could just plug that into your calculator. Let's do that. 7 divided by cosine of 30. Hit enter. We get 8.08. So let me actually get rid of this. No, come on, Moby. 8.08. And that's it. And that's how we find missing sides in triangles. Remember, you always need one side, one angle. If you guys would like to see more examples, you guys can look on the Ink Notes, which has all the answers to all of these. Or you can send me any messages or any questions if you'd like me to check your work. Let me know, and that's about it.